Hello, so now we're going to move on to look at the reactions of alkenes. We know already that alkanes don't really do much, they just burn. And we had a whole lesson talking about the combustion of alkanes and how they are incomplete or complete. So we're going to look today at how alkenes are different. Now we know where we get alkenes from. First of all, a bit of retrieval. I want you to write down all the differences that you can think of that occur between these two compounds. If you can name them, that's brilliant. So name the type of compound and name the actual compounds that you've got there. And then we'll go through and we're going to look at the alkenes in more detail. So let's see then what we have got. So hopefully you knew that the one on the left hand side was an alkane. They are unreactive. They are used for fuels. The general formula is CnH2n plus 2, and there is no reaction when added with bromine water. Even better if you said that that alkane was ethane. Moving on to the one on the right hand side then, hopefully you know that that is an alkene, specifically ethene, 2 carbon atoms, and they are more reactive because of that carbon-carbon double bond in the middle. We said last lesson they're used for plastics, and we will learn a little bit about that today. The general formula CnH2n, so number of hydrogens is always just double the number of carbon atoms, nothing else. And it has a reaction with bromine water. We just discussed this last lesson. It will turn the bromine water from orange to colourless. So what we're doing today, we're going to look at this term functional group. It's a word you're going to use frequently. You might read about it in an exam, you might see it on other videos. You need to know what a functional group is, because as we move through the rest of this unit, you're going to learn about different functional groups of organic compounds, so it's important you know what that is. Then you're going to describe the reactions of alkenes and you're going to compare them to each other. So how are they similar? How are they different? So what we can see there are a lot of different, it might seem a bit overwhelming, lots of different functional groups. So we've got alkanes, alkenes, alcohols, esters and carboxylic acids. Now if you look inside the circles, you've always got your carbons with various different things coming off them. Now what you can see on many of them, well all of them, is that you've got these R's. Now R isn't an element. R is any hydrocarbon, any alkane should I say. So an alkane, if you look at the alkane in the top left hand corner, you can see that you've got C, C and H is coming off them. And then on either end you've got two R's. Now those R's can be other, that they are other alkanes, just with one hydrogen removed so it joins on. And the reason we just put an R is because it can be any alkane. It could have 3 carbon atoms, it could only have 1, it could have 15, it could have 55. It doesn't matter because the functional group is the bit we are focusing on, the bit at the other end, should we say. So what I want you to think about is, what do you think a functional group actually means? Okay, so in simple terms, functional groups are specific groups of atoms within molecules that have very characteristic properties regardless of the other atoms. So basically, it's the bit of the compound that makes it behave the way it does. So in the alkene, it doesn't matter what's attached to that carbon-carbon double bond. It could be hydrogens, it could be anything, but it's the carbon-carbon double bond in the middle that's the functional group that makes it behave the way that it does. Alkanes don't really do anything because the functional group is just a carbon-carbon bond. Alcohols behave the way they do because they've got an OH on the end of their alkane instead of a hydrogen. Carboxylic acids, if you look at those, you can see that you've got a C double bonded to an oxygen and then an alcohol group to make this carboxylic acid. And an ester, which we'll move on to in a couple of lessons' time, it's got the C double bond O, just like a carboxylic acid does, but instead of having an OH, it's got an O and then another alkane joined on, which again changes the properties even further. So the functional group is the part of the compound that makes it behave the way that it does. And we're going to learn in turn about each of these different groups. So we've already talked about alkanes. We've already talked a little bit about alkenes. We're going to go into more detail about the reactions of those today. And then we're going to talk about alcohols, carboxylic acids, and esters in the up and coming lessons. So, as we can see, the functional group in this case of an alkene is this double bonded C. And that's what makes it behave differently from an alkane. So, what we're going to look at now are the different reactions of alkenes. What I'd like you to do is I'd like you to look at each one individually, make some notes, and then what we're going to do is we're going to put it all together in a simplified table after you've done it. So one, show you understand it, but two, make sure that you can fully understand and have an easy reference sheet to look at, because it can be quite complicated when there's several of them. So we're going to condense it into a simplified table that you can just refer back to. So the first reaction that alkenes undergo is called addition reactions. This one specifically is called addition polymerization, meaning it makes a polymer by adding together. Very, very simple. So you get many of the same alkenes. So you can see there we've got 6 different molecules of ethene. Underneath, you've got something called polyethene. And that's where those ethene molecules have undergone addition polymerization to make the polymer. So that is done by the double bond opening. Because as you can see, in that polyethene molecule at the bottom, you have no double bond. So the double bond opens in each case, allowing them to join on to the next molecule. We've got a whole lesson where we will talk just about polymers. So don't worry if you don't fully grasp it now. We're just going to touch on it, and then we've got a whole lesson where we'll go into it in a lot more detail. Now, you often get questions where you have to name the polymer. So that's the product. The monomer is the alkene that is joining together to make the polymer. And sometimes you have to work backwards and name the monomer. Now, it's very simple. There will always be help given in the question. And as long as you know the rules, it's very simple. So if you have a monomer called paperclip, bear with me, it'll make sense. So paperclip, you can join them together to make a chain of paperclips. If we say that our paperclip is a monomer, we're going to join many of them together. The paperclip chain would be our polymer. Now, the simple way of naming that is that we put the word paperclip in a bracket and put poly in front of it. The bit in the bracket is the bit that is repeating over and over again. So poly, paperclip. So if we had ethene, the polymer of ethene would be polyethene. Similarly, butene would be polybutene. Now, you might get things that you've never ever heard of and think, oh, this is really tricky. And sometimes an exam might try and catch you out by putting something of a long name that looks really complicated and automatically might make you think, I don't know this, I've never heard of it. But actually, it's still just the same method. You put it in brackets and put the word poly in front of it. So chloroethene becomes polychloroethene. Sometimes you have to work backwards, and again, this sometimes catches people out. So it might be question might be talking about a polymer, and you have to name the monomer. So all you do is take the word poly away, take the brackets away, and you end up with propene. So the last one here is a big long name, poly 1,2-dichloroethene. Very simply, the monomer is 1,2-dichloroethene. So you don't need to know anything about that polymer or anything about that monomer to name the other one. You're either adding poly in some brackets or you're taking them away. It's as simple as that. Don't let it catch you out, because it's only a 1 mark question generally, but it's the 1 mark questions that get you those extra little marks that could be the difference in a grade. So don't let yourself feel stumped because it's a compound that you've never heard of. Just think of the rules. So this is an example of what it will look like. So again, it's looking at ethene again. And obviously we can't write it out because there we're only adding 6 units of ethene together. We could be adding 1,000,000. You can't write that out. It would take you far too long, far too much paper. It's a complete waste of time and it'd end up just meaning nothing. You'd have a page full of C's and H's. So there's a shorthand way of writing these that's important that you can recreate. So if we've got there our ethene unit, we put an N in front of it. And just like before, N can be any number. That's what it means. So that is our monomer. We've got N amount of ethene. Now, when it undergoes polymerization, as we can see from the diagram above, the first thing that happens is the double bond, must open. And when that happens, we then get vertical hydrogens, or whatever's coming off it is vertical instead of on a diagonal. Now, because that's a repeating unit, that is going to repeat itself n amount of times, we put it in brackets. Now, you've got the little wavy bonds coming out the side. They don't have to be wavy, but they do need to come out of the brackets. And that shows that whatever's in the bracket is the thing that repeats over and over and over and over again. And you pop a little N down the outside of it in the bottom right hand corner to show that however many you had at the start, you have that many of those at the end. So it repeats N amount of times. Now, ethene is the simplest alkene. It's the simplest polymer because all you've got is hydrogen atoms coming off the 2 carbon atoms. It will always be 2 carbon atoms in the centre with a single bond, because if you remember, the double bond has opened to allow the next monomer unit to join. However, those hydrogen atoms that are attached where you've got those 4, those can be absolutely anything else. So if you see something that looks a bit more complicated, don't let it scare you, because you can, and I'm going to look at an example in a second, you can substitute those hydrogens for anything else and just follow the rules, break the double bond, put your brackets round, put your extra bonds at the side, and just copy what's on each carbon atom. It's very, very simple. So let's have a look at an example. So if that is our monomer, so you can see there, we've still got the N, we've still got the C double bond, but this time, instead of one of the hydrogens, we've got a chlorine. Now the polymer for that, as you can see, we've got rid of the double bond, we've put some brackets round and our new bonds going through the brackets, and the same carbon, so the second carbon atom, the hydrogen at the top is still been replaced with a chlorine. So those 2 units are exactly the same, apart from you've turned it from a monomer into a polymer. So now if you look at this example, it seems a lot more complicated because we've then got this hexagonal called benzene. You've got that in there. Doesn't need to make it any different. It doesn't need to be difficult. Same method. You get rid of the double bond in the middle. You put some brackets round, 2 new bonds, and just make sure that whatever's attached to the carbon atoms is attached in the same place. Very, very, very easy. Might be worth you copying an example down so that you know what it looks like so you can practice. And you can be asked to draw the polymer in an exam, but sometimes it gives you the polymer and you're asked to work backwards. So you just get rid of the brackets and the extra bonds and put the double bond back in the middle. It's very, very simple. Okay, so as we know, we did this last lesson. Alkenes will decolorize bromine water, and this itself is another addition reaction. So what you can see there is if we've got our alkene, this one is ethene, and we add bromine water to it. For there to be a colour change, there must be a chemical reaction going on. and it's an addition reaction. When you've got an addition reaction, it just means the two things are added together. You don't get extra compounds, it's not splitting apart, they just simply add together. So anytime an alkene reacts, it reacts at the double bond. So what happens is the double bond again opens, allowing the bromine to then split apart and join across where that double bond was initially, making sure that that carbon has still got 4 bonds. Bromine makes 1 bond, don't need to worry too much about that, but you've added the 2 bromines that were in the bromine water to the carbon atoms of the alkene. They would always join to the carbon atoms where you've got a double bond. So if you've got a longer alkene, propene, butene, where you've got other carbon atoms as well, they would always join to the 2 carbons at either end of the double bond. And this is called a dibromo compound, a dibromoalkane. That one specifically, because we've had ethene, is dibromoethene. Now this is where we get our colour change from, because bromine water, as we know, is orange, and a dibromo compound is colourless, because that is what you've now made. Alkenes can also undergo reactions with steam. So yes, water, but it has to be steam in its gaseous form. It doesn't work if you just try to add water. And what we get, and this is going to be very important when we learn about ethanol and biofuels, you get an alcohol. Now we talked at the start and said that alcohols were another functional group. They are, and we are going to have a whole nother lesson talking just about the functional group of alcohols. If we look at an example here, we've got ethene, and then we've got H2O, that's our steam, making ethanol. Now, like before when we did the polymerization and when we added bromine water, the reaction goes on at the carbons at that double bond. So what you can see has happened is that the water has added on and the OH has gone on the end to make the alcohol, and on the other carbon you've had an extra hydrogen. So one of those hydrogens from the water has gone on the first carbon atom, and then the H and the O that remain have formed an alcohol functional group on the final carbon atom. And the alcohol would always go on the last one, so it's always drawn like that. It could be flipped over and go on the first one, in this case when it's ethene, but if you've got a longer alkene, it never goes in the middle. Always draw it on that last one. Now, this is really useful, like I said, because ethanol is used as a biofuel. So we have a whole lesson when we talk about that and evaluate the different ways of making ethanol. So the conditions we need are high temperature, high pressure, and this time you need an acid catalyst. And you do need to know that it's an acid catalyst. You can't just write that it's a catalyst. So obviously the high temperature is to make the steam. The high pressure is to force these two things together, and the catalyst just speeds up that reaction. Now, just like alkanes, alkenes undergo combustion as well. And in the same way, they make carbon dioxide and water. Now, we don't use them for fuels. The reason is they make really, really smoky flames. And obviously as well, we can't just get an alkene from fractional distillation. We'd have to do cracking as well, which is adding another stage to get something that's not as good. So we can burn them. You get a lot of incomplete combustion producing carbon and soot, which we know contributes to global dimming. You get carbon monoxide, which is poisonous, as well as your carbon dioxide and water. So we don't really do this, but it does happen. But because of incomplete combustion going on more often than not, you get less energy released, which means it's not as useful anyway. So you've still got your alkene plus your oxygen giving carbon dioxide and water. When you've got complete combustion, it's just that you get less energy. They also undergo reactions with hydrogen. Okay, so where there is a mistake there, the reaction of ethene and hydrogen produces ethane. So we've got an alkene plus hydrogen gives an alkane. So there you can see C2H4, that's ethene, plus H2, which is hydrogen, giving C2H6, which is ethene. And this is what it looks like. Again, it's another addition reaction, and that addition happens across that double bond. The double bond breaks, allowing each of those carbon atoms to gain the extra hydrogen. So if you react an alkene with hydrogen, you get an alkane. Now, really specific conditions needed for this. You need 60 degrees C and a nickel catalyst. And yes, you do need to know that it is a nickel catalyst. Okay, so hopefully you made notes through that. If you didn't, go back. But what I want you to do now is we're going to summarise it, because that was a lot of information. It's really hard to remember in that format. So we want to take the key points from each bit. So I want you to draw this table, pause the video and use your notes to take the key bits out and put an example of an equation in. It can be the written, the word, the structural, the displayed, all of them if you wish, but keep it simple. So what are the products? What do you make when you do addition polymerization? What's the product called that you make? You don't need the example, you just need the general name. What conditions do you need? Do you need a certain pressure, temperature? Do you need a catalyst? Write that in there and then give an example of an equation. So pause the video and then we'll go through the answers. Okay, so addition polymerization, then hopefully you know that we make a polymer and the conditions are high pressure. It's not high temperature, because polymers are plastics. You get high temperature, they melt. So it's a common misconception because everybody just normally thinks conditions and automatically goes to high pressure and high temperature, but this one is just high pressure. So if we look there, I've just gone with ethene, making polyethene. We had on the other slide, it's the simplest format, but any that you've used. Just remember that the polymer must have the brackets and the extra bonds going through the brackets. They don't have to be wavy though, and don't forget those ends. So addition with bromine, we make a dibromo compound. The conditions, we just need bromine water. And there is our example. Again, I've kept it simple with the ethene making dibromo ethane, sorry. So steam, alkenes plus steam give an alcohol, and you need high temperature, high pressure, and a catalyst. And your equation, so I've got both the word equation and the displayed formula so you can see what exactly is happening. So ethene plus steam would give ethanol, which is an example of an alcohol. So you've got your ethene there with your double bonds in the middle, your water, the double bonds opened to make what looks a bit like an alkane, only it's got OH on the end instead. That's your alcohol functional group. So combustion of alkenes gives carbon dioxide and water. You need heat and oxygen. Now that wasn't on the slide, but we did do combustion of alkanes. And if we think about that fire triangle, you need the fuel, which would be the alkene in this case, oxygen and heat in order for burning combustion to take place. So you've got your example there, which was on the slide, ethene plus oxygen gives carbon dioxide and water, and it's balanced there for you. So lastly, when you react an ethene with hydrogen, you get an alkane. You need 60 degrees C and a nickel catalyst, and that's an example of the chemical equation for it. You could have also drawn out the displayed formula. Okay, so what we're going to do now is we're just going to use all that information. The sheet of questions is on class charts. We're going to quickly answer those questions to see how much you've understood. It was a lot of information, so practicing getting it onto paper and showing your understanding is the best way to go about it. So have a go at the questions and then we'll go through them. Okay then, so crude oil is used to make useful substances such as alkenes and plastic. Which is the correct formula for ethene? It is the middle one, C2H4. The next one, the name of the plastic formed, so plastic being polymer, when many ethene molecules are joined together, would be polyethene, top one. read the article and then answer the question. So, 1 million tonnes of plastic are made from crude oil every year. Most of the litter found on beaches is plastic waste. 80% of plastics produced end up in landfill sites. Draw a ring around the correct answer. Plastic waste needs to be removed from beaches because it is not biodegradable. Suggest a problem caused by 80% of plastics going to landfill sites. Okay, landfill sites are filling up, there's not enough space, there's not enough sites, something along those lines. Suggest one way of reducing the amount of plastics going into landfill sites. Recycle or burn them. Now, obviously, burning's not very good, but you could put that as an answer. You could also have use alternative materials that aren't plastic. You couldn't have, in this case, reuse. It did not let you have that answer. Now, hopefully what you can see with these questions is you'll have a question based on something like an alkene or an alkane or an alcohol, and they bring it round to an everyday scenario. Now, another unit in the chemistry is to do with sort of environmental, and you touch a little bit on recycling, but not a great deal. So they often make links and get you to use your own knowledge of world problems, if you will. So they've got you there thinking about the relevance of plastics and thinking about recycling and landfill sites. So don't be surprised if that comes up and you think you're a little bit stumped because you thought you were going to be answering a question just about a plastic, and then they've suddenly gone into recycling. That is often done. They make links to other topics in science and the wider general sort of just general knowledge. Hopefully you found this useful. If you've got any questions, drop me an email, and tomorrow's lesson we'll be learning a bit more about alcohols.